Hello, everyone. It's Mrs. Tiller, and we are going to continue with Unit 11-2. I've got in front of me here the notes that I did in the last video last week on area of trapezoids, kites, rhombi, and squares. And we're going to continue in the same packet. This is the packet that you picked up before the break, and also remember, if you did not pick it up, I did post it to Edsby. This is also the packet that contains the 2 assignments that are due today, which is March 30th, and tomorrow, which is March 31st, the worksheets 11-1 and 11-2. So as you can see here, here's your 11-1, and then in the back of the packet, of course, was the 11-2 worksheet. On the next page here, I had accidentally printed the repeat of 11-2, so you don't have to worry about that page. The next page here, these are the diagrams that I'm going to use today for the notes. And this page, I printed the same diagram smaller, so that way what you can do is after I've gone through the notes today, you can always go back and you can redo these questions on this page and see if you can get the same answers that we got in the notes, okay? So this is where we're going to start here. We're going to do a couple different topics today. We're going to figure out the area of a compound polygon. You can see here in number 1, this is a compound polygon because we have a rectangle and a square combined. We can also, if you were going to look this up to try to find additional information on it, another word that's sometimes used to describe these polygons would be composite. So for those of you trying to look for extra resources, this would be another word to describe the same topic. Okay? We're also going to look at finding the a base of a trapezoid given an area, so working backwards to find the base. And then finally, we're going to do these couple of examples, finding the area of shaded regions in polygons. What I did on mine is I just used a colored pencil to color in some areas darker to make them more bold. If you'd like, you can do the same thing on yours. As a reminder, in general, protocol for these videos is definitely pause and rewind and so forth if you need to as we're working, okay? So we'll start with this example here. The rectangle and the square have an equal area. The rectangle is 12 feet by 21 feet 4 inches. What is the perimeter of the entire hexagon in feet? Okay, so first of all, you notice here that we're saying we have a hexagon. So, you know, many of us think of a hexagon as a regular hexagon, definitely not looking like this, but this is a hexagon because it does have 6 sides. If you go around and you count, you've got 1, 2, 3, 4, 5, 6. So there are 6 sides here, okay? So let's label the information that we have and remember what we're looking for, okay? So in the end, the final answer is going to be the distance around this figure. So the perimeter that we're looking for, I'm gonna go ahead and I'm gonna highlight this. You could do the same. We're looking at the distance around this figure. That's our final answer, okay? So that, as you can see, I didn't highlight it. That's not going to include this segment here because that's inside the hexagon. So the hexagon is the L shape that we're looking at. So the rectangle itself is 12 feet by 21 feet 4 inches. And so we can assume here that the 12 feet that we're talking about is this shorter distance right here. So that's 12 feet. And at the same time, of course, since I know I'm going to be looking for the perimeter, I'm going to go ahead and I'm going to label this side also 12 feet. And this distance here is 21 feet 4 inches. Okay. Now I can see I've got feet here, so I'm going to go ahead. I'm going to change this. We know that there are 4 inches in a foot, and a foot has, or excuse me, there are 12 inches in a foot. And this is 4 inches, so that's 1/3 of a foot. So we'll say that this is 21 and 1/3 feet. okay? So we want to figure out what the perimeter is of the entire hexagon, which means I need to also know this length here, this length here, this length here, and this length here to be able to add those all up. But the key that we see right here is that the rectangle and the square have equal area, okay? So my strategy here is if I find what the area is of the rectangle, I will know it's the same as the area of the square, and I know the area of the square is going to be a side times a side. So if I just find the square root of the area, I'll find the length of each of those sides, and I'll be able to find the perimeter of the hexagon. So that's my plan, okay? So the key here again is that we know the area of the rectangle is going to equal the area of the square, okay? So let's go ahead and find the area of the rectangle. We know that the area of the rectangle is going to be its base times its height. And the area of the square, of course, is going to be its side squared. So, you know, if I wanted to, I could call this length the base, this length the height, or vice versa. It doesn't make any difference. So I'm going to calculate that area. I've got 12 times 21 and a third. Okay? And I know that's going to be equal to the side squared, right? So I can call, like, say, this side side times side is going to be side squared. So if I multiply 21 and a third times 12, and I've already done this ahead of time, it comes out perfectly as 256. That's going to equal side squared. Now, of course, when I do this, you know, you do verify. Have your calculator available. See, I've got mine available here. Have your calculator available and verify your calculations to make sure you can get the same results as I did. Okay? So to get the length of this side, we'll take the square root of both sides. And I know length can only be positive, so I'm not going to worry about a negative 16. I know I'm going to have a length of 16 feet for the side of the square. So I've got 16 feet and 16 feet. And of course, I can copy over to here. I know that this is 16 feet. Okay. And think about for a moment, I don't want to tell you, I want you to think just for a moment, you know, if when we're looking around this hexagon, I've got 1, 2, 3, 4, 5 of the sides. I don't have the 6th side here. Okay, so think about for a moment, you know, what can I do to get that 6th side? So I'm pausing. And if you want, you can even pause the video. Well, the trick here is, look, if this side's 16 feet, then this piece right here has to be 16 feet, right? And remember that if I want this piece, all I need to do is take the full length of the height and subtract the length of this piece. So this length right here is going to be 21 and a third minus 16, or 5 1/3 feet. Okay. And also another thing to notice here is, of course, I have this full length here. This full length is going to be 28 feet, right? 16 and 12 make 28. Okay, so I can go ahead and I can find the perimeter now of the hexagon. I've got all the lengths of my sides. So the perimeter is going to equal 28 plus 21 and a third plus 5 1/3 plus 16 plus 16. Oh, and I left out the 12 right here, and plus this 12. The way I can check myself too is you can always just count up sides. 1, 2, 3, 4, 5, 6. Okay. So I've got all the pieces there that I need. I add that together and I find that my perimeter is going to be 98 2/3 feet. And if I want to convert it to, you know, feet and inches, because in the beginning I had feet and inches, we know that 2/3 of a foot is going to be 8 inches. So I could say 98 feet, 8 inches is the perimeter. Okay. All right, let's look at number 2. Number 2, we are given an area of a trapezoid and we need to find the base. So in this case, we have the trapezoid. We need to remember that the area formula for a trapezoid is going to be 1/2 of base 1 plus base 2 times the height. Okay, so when I say I want to find the base, what I'm really saying is I want to find the value of base 1. Let's call this base 1. Okay, so we can say this is base 1, this is base 2, and this is the height. Okay, so what I'm going to do is take all the information I'm given. I already know the area is 126 square inches, so I'll fill that in. Base 1 I'm calling B, so I'll fill that in. Base 2 is 16, so I'll fit that in. And H is 9. Okay. So as far as calculating here, remember that the order I multiply in doesn't matter. I'm going to go ahead and take 1/2 of 9 and get 4.5 times B plus 16. Okay. Now you have options here. I know some of you might tend to distribute. What I suggest though is even simpler. We can divide both sides by 4.5 and then isolate the value inside parentheses. So I'm going to divide by 4.5 on both sides. And I've got B plus 16 equals 126 divided by 4.5, which is 28. Okay. I will then, of course, subtract 16 from both sides, and I'll end up with 12 inches for the base. Okay. So again, pause the video if you need to. All right, so let's look at the back of the sheet. We're going to look at the area of shaded regions now. And I'm going to do both of these in 2 different ways. Sometimes, in certain cases, you'll notice there's a shortcut that you might notice from the beginning. So you might want to take a moment and kind of think about the diagram and think about how you might do it even a shorter way. I'm going to show you one way, and then we'll kind of look at a shortcut as well. Okay. So I think for most of you at first glance, you would notice here that we have a rectangle, and the unshaded areas of this rectangle are actually parallelograms. So we have a parallelogram here, and I'll just abbreviate that P-gram to make it shorter, and we have a parallelogram here as well. Okay. So if we think about how I can get the area of the shaded region, in many, many cases, the only way to get the area of the shaded region is by taking an area of a larger region and subtracting another area that we know to get the area of the shaded region. So I'm going to do it that way just because in many cases that's the way you'll have to do it, and then we'll kind of look at a shortcut at the end. So the area of the shaded region is going to equal here the area of the rectangle minus the area of the P-grams, of the parallelograms. Okay. So as far as formulas for this, the area of the rectangle we know is going to be the base times the height of the rectangle. So the area of the rectangle, let's go ahead and work that out. So we know we've got the base here is 9, the height is 13. I think we can all do that without writing a formula. So we've got base times height is 9 times 13 for the rectangle. And we've got 2 parallelograms, okay? So we have 2 of those. So keep that in mind, there are 2 of those. So we're going to take 2 times, and again, for the area of a parallelogram, we have a base and a height. So we can consider, if we kind of rotate the paper here if you want, you can kind of notice here that you've got a base here of 2. And for the parallelogram, of course, there's a height of 9. Because it's the same as this side of the rectangle. So if I do multiply the base times the height there, I've got 2 times 9. And again, I multiply by 2 because there are 2 of them. And if we do the multiplication and the subtraction, we'll get the area of the shaded region. So 9 times 13 is 117. 2 times 2 is 4 times 9 is 36. If I subtract, I'm going to get 81 square centimeters for the shaded region. Okay? So that's my answer. But I want you to think about what happens, let's say. I'm going to put a star over here, and we'll do this the other way over here. I'm going to say, or notice what happens if I squash this rectangle. Okay? If I squash this rectangle, notice what happens. I've got one side is still 9, but if I squash this rectangle, basically when I say squash it, basically make the parallelograms go away, what you're going to end up with is, look, I'll end up with a 9 centimeter by 9 centimeter square, because 13 minus 2 minus 2, 13 minus 4 gives me 9. So I end up with a 9 by 9 centimeter square. Okay. And of course, what's the area of that? The area is equal to the side squared, or 9 times 9, which is 81. And notice, if you notice that you could have squashed that figure, you'd get the exact same answer. And it would have taken you a little less time. Okay. Now again, that's not always going to work. In many, many cases, we find area of shaded by subtraction. Okay. Let's look at this last example for this video. Okay. I want to find the area of the 2 shaded triangles. Okay. So again, first we're going to do this by looking at subtracting. Okay. So what I'm going to do here is I'm going to highlight the larger figure that I have. And you'll notice, what shape is that? We've got 2 bases that are parallel, so we know that we have a trapezoid. Okay? And so if we think about, if I want the area of the shaded region, the area of the shaded is going to equal the area of the trapezoid minus the area, and think about that. If I want the shaded region, the space that I want to take away is the unshaded triangle. So minus the unshaded triangle. Okay? So for the area of a trapezoid, we know that, again, the formula we're going to use is 1/2 of base 1 plus base 2 times the height. And for the area of the unshaded triangle, we'll just do 1/2 of base times height. So we need to fill in the correct values here. Okay. So as far as for the trapezoid, we can call 12 base 1 and 20 base 2. So I'm going to say 1/2 of 12 plus 20. The height, of course, is over here at 4. Okay. And we also have here, now for the base of that triangle, you have to think about what the base is of that triangle, right? And what you'll notice here for the base of that triangle, if we have these this whole base here is 20, each of these triangles are going to have 10 centimeters here, 10 centimeters here. So we can conclude here that this, that we've got basically these two triangles are going to have bases that are half the length of this entire triangle, but be very clear that this triangle is not congruent to these two, so this triangle has a base of 12. Okay, so I'm going to use that 12, that base 1, 12 is going to go here, and of course the height of that triangle is the same as the height of the trapezoid, which is 4. Okay, so we've got 1/2 of 22, or excuse me, 32. 32 times 4 minus 1/2 of, we can just multiply that together, 1/2 of 48, which is 24. And 1/2 of 32 is 16, times 4 is 64. So 64 minus 24 is going to give us 40 square centimeters. Okay. Now again, I want you to notice an alternate method here. Okay, so again, here we did this by subtracting out the unshaded area. But again, think about that I could have actually just calculated these areas directly in this case. Okay, so if we kind of draw this diagram again, just notice here that what you have are two shaded triangles. And in this case, I could have just, if I wanted that shaded area, I could have just added them up directly. So remember, if this whole length was 20, each of these triangles had bases of 10. So I have a base of 10 here, a base of 10 here, and I have a height of 4. So each base is 10, height 4. And all I would need to do is the area of the shaded is equal to the area of the two triangles. And so I would just say 2 triangles times 1/2 of base times height. And of course, the base here is going to be 10 for each triangle times the height, which is 4. And if you multiply that out, 2 times 1/2 cancels out. And you get 10 times 4 is again 40 centimeters squared. Okay. Now, I would say for this one, many of you would have noticed the fact that you could have calculated the area of these two triangles directly, and that's probably what you might have thought of even before doing the subtraction. Whereas up here, most of you would have not seen that ability to squash the pieces of the rectangle together. So you can see I showed in both cases because I want you to understand you have to consider different options. Sometimes you'll see one method, sometimes you'll see another. Okay. All right, so that'll complete this video, and I'm also attaching worksheets that go along with this, and I'll also be doing one more video in this post as well. Okay, have a good day. Bye-bye.